Hey, college algebra kids. In the last video, we looked at multiplying and dividing rational expressions. Today, we're looking at adding and subtracting rational expressions. Notes out, and away we go. Let's recall from, again, 4th and 5th grade fractions. If we're adding fractions that have the same denominator, all we have to do is add the numerator. So 1 plus 1/7 plus 3/7 is simply 4/7. Right? If we're subtracting fractions that have the same denominator, it turns into subtraction. I could actually rewrite this first one, which I should have done, as 7 over 1 plus 3. If they have the same denominator, we can rewrite the fraction with one denominator, 1 plus 3. Same thing on the second fraction. This becomes, because they have the same denominator, 3 minus 2 in the numerator, which is 1/5. We're going to use that same rule for adding and subtracting rational expressions with the same denominator. For example, letter A, 3 over 2x plus 5 over 2x. They have the same denominator. So we can rewrite this as 3 plus 5 over 2x. That simplifies, which is 8 over 2x, which we can simplify by dividing by 2. That leaves us with 4 over x. So again, if they have the same denominator, we can just add and subtract. Letter B, same thing, x minus 1. This becomes then 5x minus 3 plus 5 minus 7x. If you want to do that all at one time, you probably could. 5x minus 7x is minus 2x. Negative 3 plus 5 is plus 2. And we want to factor the numerator, and so that will actually factor out a 2. So I'm actually going to factor out a negative 2. That's going to leave me with x minus 1 over x minus 1. And what happens? Well, those are the same. They cancel, and we're left with negative 2. That's why we want to factor everything, because there may be a hidden polynomial that will cancel. So go ahead and factor everything. Letter C, here we want to subtract. We're going to do this the same way we did in the polynomial chapter. Instead of thinking about this as a subtraction, we're going to think about adding the opposite. I'm going to add the opposite, so negative x squared plus 2x minus 1. If you can still think about it as subtraction, good for you. And I'm going to do this in one step. So now I have x squared plus negative x squared. That cancels. 4x plus 2x, right? That was minus and negative, which becomes plus. 4x plus 2x is 6x. And then 7 plus negative 1, right? 7 minus 1, either way you want to think about that, is plus 6. Again, I want to factor to see if anything will cancel. Out of the top, we can factor out a 6. That leaves us with x plus 1. Notice the denominator factors difference of two squares, x plus 1 times x minus 1. There's our hidden polynomial that cancels. We're left with 6 over x minus 1. What if the denominators are not the same? Then we need common denominators. How do we get common denominators? Well, the smallest number that 4 and 6 will divide into is 12. And so we want to rewrite this as a 12-something plus a 12-something. How do we change them to 12s? Well, to get 4 to become a 12, we can multiply it by 3. If we multiply the bottom by 3, we have to multiply the top by 3. To get the 6 to be a 12, we have to multiply by 2. And so we're left with then 3 12s plus 2 12s. Now we have same denominators. We can add 3 plus 2 is 5. We're going to do the same thing with polynomials using the least common denominator. The least common denominator is the smallest polynomial of which 2 or more polynomials are factors. We're going to start small, and we'll work our way up. First off, let's just practice finding the least common multiple. So now we're not finding the greatest common factor. We're actually finding the biggest polynomial that both will divide into. So instead of finding what they have in common, we want the maximum of the most of what they have. What's the smallest number that 4 and 6 will divide into? Well, we just did that. That's 12. You can go bigger, but then you're just making it harder on yourself because you have bigger numbers. Now for the variables, instead of what they have in common, we want the most. So what's the most x's they have? Well, that's an x squared. What's the most y's they have? That's the y's. So for the numbers, we want the biggest number that both will go into. The variables, we want the most for the least common multiple. The greatest common factor was what they have in common. We want the most. These are all variables, so there's no numbers. We want the most variables they have that appear, not in common. So for A, what's the most? Well, that's 3, so A cubed. B's, what's the most? That's, again, B cubed. And C, there's a C squared. So there's our least common multiple. Letter C, again, what do we always have to do? We need to factor first. So multiply to give 6, add to give 5 is 2 and 3. Multiplies to give 9, adds to give 6 is 3 and 3. So what is our least common multiple? Well, on this side, there's an x plus 2 and an x plus 3. On this side, there's 2 x plus 3s. So we need 2 x plus 3s. So there is our least common multiple, x plus 2 times x plus 3 times x plus 3. You could also write that as x plus 2 times x plus 3 squared. Remember our rule, this is x plus 3 squared. We need the most number of times it appears because there's 2 x plus 3 squareds here. We need 2 of them in our least common multiple. And here we go. So 3 over a squared b plus 5 over ab squared. First, we want our least common denominator. For our variables, that's the most they appear. There's an a squared, there's a b cubed. So we're going to rewrite this in terms of a squared b cubed plus a squared b cubed. Hopefully later on you can skip this step, but for now we're going to do this step. What are they missing? For a squared b to be a b cubed, it needs a b squared. If we multiply it to the bottom, we have to multiply it to the top. So here we have a 3b squared. The ab cubed is missing what? It's missing the second a, so we're going to multiply by a. And so that's a 5a. Now we have common denominators, and we just need to add the numerators. 3b squared, they don't really combine, it's just that, over a squared b cubed. Nothing cancels, we're done. So again, we're looking for that least common denominator, and then we can add the numerators. Here, what's our least common denominator? Well, we've already done 6 and 4. The smallest number that 6 and 4 both go into is 12. So we want to rewrite this as 12 something minus 12 something. For a 6 to be a 12, it needs a 2. So we're going to multiply the numerator by a 2. That's going to be distributive property. To get a 4 to be a 12, we're going to multiply it by a 3. So we're going to multiply the numerator by a 3. Now, when we do distributive property, we get 2x plus 2 minus 6x minus 9. Now we have common denominators, and we can subtract the numerators. 2x minus 6x is negative 4x. 2 minus the negative 9 becomes plus 9. 2 plus 9 is 11. There are no similar factors, and so we're done. We're just going to kind of steadily work our way up here to bigger and bigger problems. 1 over x squared minus 1 plus 2 over x squared plus x. First thing we need to do is factor. So this is the difference of 2 squares, x plus 1 times x minus 1, plus, this factors out a greatest common factor of x, leaves us with x plus 1. So 1 and 2. Now what's our least common denominator? Again, we need the greatest number of that things appear on each denominator. So here we have an x plus 1 and an x minus 1. Here we already have an x plus 1, but there's also an x. So the x goes out front. There's our least common denominator. Now we're going to come back and multiply by what the denominator is missing. What is this denominator missing? It's missing an x. So we're going to multiply an x times the numerator. This side is missing an x minus 1. That simplifies. We can actually make this a 2x minus 2. Now we have our least common denominator. That is x times x plus 1, x minus 1. Again, we're going to leave this all in factored form. Now we can do our addition. X plus 2x is 3x. And then minus 2. Nothing cancels. And so we're done. Letter B, what's our least common denominator? Well, they kind of look the same. A minus 2, 2 minus a, but the negatives are wrong. So what are we going to do? We're going to use our trick. So I'm going to pull out a negative on the first fraction, and that's going to make this a negative a plus 2. Now we have common denominators, and so this is negative a plus 2. I'm just going to rewrite this with a negative 5. The negative floats. It can go where we need it, so it goes to the numerator. Minus a 3 over 2 minus a. These are the same denominators. They're in reverse order, but that's okay. Negative 5 minus 3 is negative 8 over 2 minus a. You could write this. The negative actually could multiply by the 2 minus a. So this could also be 8 over a minus 2. I'm going to see those as the same thing. So whichever one you put in your homework, would take that either way. Again, we're looking for the least common multiple, least common denominator. This one has a 4x. This one also has a y. So our least common denominator is a 4x and a y. We need each factor the greatest number of times it appears. And so what's the first one missing? The first one's missing a y in the denominator. So I'm going to multiply by another y. That actually gives me a y squared in the numerator. This one's missing a 4. So I'm going to multiply by 4. Now my least common denominator is 4xy. I'm going to have then 2xy squared plus 4x squared. Again, we want to factor. The numerator will factor out a 2x as the greatest common factor. That leaves us with y squared plus 2x all over 4xy. Why do we do that? Again, we can't cancel through plus and minus, but this is multiply. Because this is multiplied with the parentheses, we can cancel the 2 and the 4 to leave a 2, and we can cancel the x. So we're left with y squared plus 2x over 2y. That one does have a shortcut. Remind me in class, and we'll talk about what that shortcut is. There's our answer. We can't cancel the 2's because the y doesn't have a 2. We can't cancel the y's because the 2x doesn't have a y. There has to be a factor in each term to be able to do that. And that's actually the shortcut. Letter B, we want to do the same thing. We want to factor first. Then we're going to look for our least common denominator. The numerator factors out at 8. That leaves us with x minus 1. The denominator will factor out a 4. And that leaves us with x squared minus 1, which is the difference of two squares, which is x plus 1, x minus 1. Minus 9x over. This will factor out a 3, and that leaves us with x squared minus x minus 2. That will factor x minus 2, x plus 1. Now this one actually has a trick to it. And that trick is sometimes if we simplify first, then it's easier to do our least common denominator. Notice 8 and 4 will cancel, leaving 2 and 1. X minus 1's cancel, so that gets that out of the denominator. And I left the 3. The 3 and the 9 will simplify, leaving a 3 and a 1. So then what's left, let's rewrite this mess. And so now we have a 2 left over an x plus 1 minus a 3 over an x minus an x plus 1 and an x minus 2. So sometimes it helps to simplify first, then our least common denominator gets a whole lot easier. So what's the least common denominator here? Well, they both already have an x plus 1. This one's missing an x minus 2. So this one's going to get an x minus 2. And so we have x plus 1 times x minus 2 is our least common denominator. Now we're going to simplify the top. 2 times x is 2x. 2 times minus 2 is minus 4. And then we're going to subtract 3. That's minus 7. That doesn't factor. And so we're done. I left off the x. I apologize. That was a 9x. That's a 3x. So that should be a, it doesn't subtract correctly. So that's going to be a 2x minus a 3x. That's a negative x minus 4. So negative x minus 4 over x plus 1 times x minus 2. I missed that x. So again, it's tricky not to lose pieces as you're going through. Just a couple more. Again, we want to factor first. And so this factor is difference of two squares, x plus 2 times x minus 2, all over 2, minus 5 over, this is going to factor x, multiplies to give negative 10, subtracts to give minus 3 is minus 5, x plus 2. So what is our least common denominator? Well, that's got to be x plus 2, x minus 2. And then we already have the x plus 2. We need the x minus 5. Again, each factor, the greatest number of times it appears. Therefore, what's missing? The first fraction is missing the x minus 5. So we're going to multiply it by the x minus 5. The second fraction is missing the x minus 2. So it's going to get the x minus 2. Again, don't be afraid to rewrite this as many times as you need. So this is x minus 5, x plus 2, x minus 2. Now I'm going to multiply the numerators to get 2x minus 10 minus, don't forget this is a minus, minus 5x, distributive property. This is 5 times negative 2 is minus 10, but it's minus a negative 10, which makes it a plus 10, which means minus 10 plus 10 cancels. 2x minus 5x is negative 3x, and that's all over our common denominator, x minus 5, x plus 2, x minus 2. And last one, x over 2x squared plus x minus 1 plus 3 over 3x squared plus 2x minus 1. Again, the first thing we want to do is factor to see how to get our least common denominator. This thing's going to factor. Signs are different. Multiplies to give 2x is 2x and x. We need to multiply and subtract to get a plus 1. So that's going to be a plus 1 and a minus 1. And that should get us, there's our negative 1 plus 2. There's our 1x plus 3 over, this one's going to factor 3x and x. Signs are different. We want a plus 2, so it's got to be a plus 1 and a minus 1. Usually what's going to happen is one of them will be the same. So if you get stuck factoring, look at the other polynomial to see what the terms were, and that will give you a clue about what it might factor into. So what is our least common denominator? We need a 2x minus 1. We need an x plus 1. The second parenthesis already, or the second fraction already has an x plus 1. We need a 3x minus 1. Therefore, what are we going to do to multiply? The first fraction needs a 3x minus 1. The second fraction needs a 2x minus 1. And here we go. So our common denominator is 3x minus 1 times 2x minus 1 times x plus 1. We're going to distribute a property in the numerator. That's 3x squared minus x plus 6x minus 3. And our final answer, unless it factors, then we got to keep going. 3x minus 1 times 2x minus 1 times x plus 1. That's 3x squared plus 5x minus 3. And that will not factor. And so we are done. Homework for adding and subtracting rational fractions is section 6.3, page 404. We're doing 8 through 18 evens and 38 through 56 evens. Good luck, Maroons. See you in class. Have a good day.